Hello, and welcome to your latest tutorial with your friendly TA, Ray, the Psychologisaur. Today, we're going to be talking about neuron anatomy and synaptic transmission. So what's this? Why, it's a neuron. That would be the smallest working unit of the brain. So it's essentially a brain cell. So what on this looks the most like a cell? That's where we'll start. Well, this is our cell body. Pretty familiar. Now, what do typically all cells have? A nucleus, right? This is elementary biology. We've got this. But when it gets more complicated and needs distinction is what happens here versus here on our neuron. So to help us out, let's think of an analogy of a tree. So these are our roots taking in nutrients for the tree. And here, the branches are moving out. So this is sort of our output. So input, output, roots and branches. So the word for these roots is dendrites. So these dendrites are taking in information. They're sort of listening. And they're taking that information, moving it down until it branches out into what's literally called a branch. To be specific, terminal branches. And on the ends of these branches, we have terminal buttons. These buttons kind of look like weird alien fingers, right? They're tapping the next neuron like, hey, check this out. Output. Staying with the tree analogy, what's this area? Well, if we were going to chop on it, this would be the part that we would put our axe on. Our axon. And what's this sort of lock holding it in place? Well, let's call the axon hillock. And this is our action potential start, moving down our axon. So what are these things? Well, they are what they may look like. They look like something like a sword or a knife would be covered into insulate, so a sheath, right? And that's precisely what they do. They insulate, myelin sheath, and this helps communication go faster down the axon. Now, what are these spaces in between? So, we think of a common mountain around here, maybe, like Mount Rainier. And they got roads, right, on the mountain. So, the way I remember it is nodes of Ranvier. Nodes in between, nodes of Ranvier. The really cool stuff though happens when the neuron talks to the next neuron. So when these guys talk to the dendrites on the next neuron. So let's check that out. So what we're looking at here is the terminal button of one neuron talking to the dendrite of the next neuron. See, it sort of even looks like a mouth doing the talking, and then the cup of the ear listening. The space between? Well, that is our synapse. So what's happening before? This is presynaptic neuron, after postsynaptic neuron. And this is our synaptic cleft, or our synaptic gap. For our purposes, this is going to be club synapse. Ounce, 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 ounce. So what are these guys doing? Well, these are our neurotransmitters. And they want to go to the party at club synapse. But they're in their vesicles, or their vehicles, vesicle, and they're waiting on some action. They're waiting on the action potential to come out and stimulate their release into club synapse. Ooms, 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 ooms. So what are they doing once they're there? Well, they can come down into the receptor on our postsynaptic neuron, and they can sort of open the door for their cool friends, the ions, to rush in, VIP style, right? And make some changes happen. These guys don't actually get to come into the party, but they get to party in the gap, ooms, 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 until something comes along, like an enzyme, woo, woo, party's over, and dissolves our neurotransmitter, or he'll float around until he's like, I think I'm getting tired, I might just go home, and he has reuptake into our presynaptic neuron. All right, we're going to keep it short and sweet. Study up and have a great week.